check out this awkward tube. Well, this awkward tube has surface area. It has half of a sphere here and half of a sphere here. So I really have two halves of a sphere. If I didn't have the cylinder in the middle of it, I could close the whole thing together and I would just simply have one entire cylinder, sphere. Now, I also have a cylinder, but I'm not going to find the full surface area of the cylinder because what I really have is this situation where I've got this little tube wrapped around, pardon all the scrap work, but we got this little tube wrapped around, and that tube has a hemisphere here, half a sphere, hemisphere here. So I'm not going to count the circle here and the circle here. So if I'm dealing with the surface area of a cylinder, in this case, I'm not counting circle and circle, so I'm not going to count the 2 pi r squared. I'm just going to count 2 pi r h. So let's do that. So plus 2 pi r h. Again, this is not a situation where you necessarily memorize formulas. You just think intuitively of what it could be. So we know that the radius is 6 and the height of the cylinder, not the entire thing, but the height of the cylinder would be 11. So 4 times pi times the radius squared plus 2 times pi times the radius times the height. And we're going to do this one first in terms of pi and then not in terms of pi. So 4 times 6 squared plus 2 times 6 times 11. And that's going to give us 276 pi. And we'll put units on this as well. This is square meters, which is also equal to, multiply that by pi, and we're going to have 867. 867.080, if you want to get technical, square meters on that one as well. All right, for this next one, we have interesting situation here. Now, if you want to ignore that hemisphere on the top, go for it. And I'm actually going to do that. So I'm going to pretend like the surface area of this is only going to involve just the box you see, this rectangular prism. And in this situation, if it really helps, you could draw a little bit more. You could be like, oh, well, there's this, and there's this, and there's this, and you know, and it's going to go up into this corner back here that you can't see. And you're going to have two 8 by 12 sections. So we're going to have two of everything that's about to happen. We're going to have an 8 by 12. And we're going to have, now front and back is going to be 8 by 8. So 8 times 8. And then we're also going to have two, and here's your two, built in already, two left side and right side. Okay, so here's what just took place. Let me write a couple things down. If you want to follow along with what I'm doing a little more specifically, let's use red. This 8 by 12 is the top and the bottom. And this 8 by 8 is the front and the back. And then we're going to do another one that's 8 by whatever that is, which is also 8. So 12 by 8, I should have said. 12 by 8. And this is going to be the left and the right. Now, hopefully you're noticing a few things here. This top and bottom and the left and the right are the same thing. They're both 12 by 8. So I really could combine this one and get two of them and then double that and get four of them. Not going to go there. Just don't want to. Okay, that would be if that hemisphere wasn't there. But that hemisphere is there. So we need to add the surface area of half of a sphere, and that would be, I'm going to write a little too much here, 1/2 4 pi r squared. That will become a 2. Now, but here's also the situation. All right, so there is a circle that is up here, where this hemisphere sat down on top of it. Now, if I didn't have that hemisphere, I would just have this right here. Well, as soon as I plop that hemisphere down, here's the surface area of that dome, but we have covered up this circle. So we're not going to count that circle anymore, so let's subtract the thing that we counted a little bit too much of earlier. So pi r squared. So minus 1 pi r squared. So let's keep going with this. We're going to have 2 times all this, and we have radius as well. The radius, oh my goodness, what's the radius? Well, let's figure it out. If the whole distance across here is 8, then this distance must be 4. So the radius is 4. That's going to come in handy. Feel free to write that if you would like. So let's keep going. I'm going to go ahead and figure this part out. I just find it necessary. So we're going to have 2, and then 8 by 12, actually, times 2, because there's that one and there's that one, and then plus 8 times 8, which of course is 64. So we're going to have 512 plus, and then I'm going to go ahead and write all this out again, sort of. This is 1/2 times 4, so 2 pi r squared minus pi r squared. And if you want to take this out an extra step, you can do 512 plus, let's see, 2 minus 1 is going to give me 1 pi r squared. Interesting. So 512 plus pi times, we know the radius is 4. You could have plugged that 4 in way up here. Totally would have been fine. I just didn't. So 512 minus pi times 4 squared. 461,735, and this is square centimeters.